Today I am going to discuss about another interesting serial data transfer protocol, that is I2C. It has got one of the most attractive feature, that is it uses minimum number of lines or minimum number of ports for data communication. If you see in UART, at least 4 to 5 lines, transmission lines are required, connections are required. So each connection means you are consuming a space in the chip. So if you increase the number of lines, thereby you are increasing the chip area. Similarly, if you see SPI, serial peripheral interface, that requires 4 lines. But I2C, this is developed, this technique was, or the technology was developed by Philips. So this is inter-integrated circuit, I2C, inter-integrated. That means inter and intra. Intra means inside. Inter means we have different number of chips, they are interconnected. International, inter-chip, inter-integrated chip. So they communicate between more than one integrated circuits. There may be the integrated circuits, may be memory, maybe any peripherals, or it may be any microcontrollers. In modern day automobiles, the number of controllers is about 40 or 50, maybe more than that. So in order to communicate inter-device communication, they are using this protocol. And also within an IC integrated circuit, there are subsystems are there. Subsystems are communicating or data transferring in between them is through this protocol. So let's see. Pronounced as I2C. It's two-wire serial bus protocol. So in your MAKAUT question paper, I have seen there was one question, describe a protocol, serial data transfer protocol using minimum number of lines. So this is the protocol which are using minimum number of lines. Okay, so this is one of the most interesting feature of this I2C protocol. This is invented by Philips, electronics giant from Holland, Netherlands, in early 1980s. Okay, and so originally used by Philips inside television sets. You know, you must have have you seen television set? Now you can see television set from LG, Samsung, mostly Korean or maybe Chinese or Japanese companies. They are dominant in the market, but earlier days Philips used to manufacture televisions. So within a television, there is in the circuit, the PCB board, there are various chips, controllers are there. So communication between controllers in a circuit used to be done through the technique they used is I2C. Now very common in peripheral devices intended for embedded system use. So why it has become popular because in a embedded system, apart from microcontroller, you are using uh, some other subsystems in order to, and these subsystems are very much nearer to the microcontroller. So whenever you want to transfer data in between systems, microcontroller and let's say another memory device, they are very closely placed in a PCB, then this protocol is used. So Philips, National Semiconductor, Zycor, these are famous companies, and Siemens, they used to follow this protocol. Also used in the PC world. So real-time clock is attached to the processor through this communication link, that is I2C, and temperature sensors in a system, they use this one. With two-wire serial protocol with addressing capability. Why addressing capability is required? Because actually transferring data means you are transferring from microcontroller, it is sending some data, or you can say you are writing some data outside memory or in any port or any system, and reading means, and receiving data means reading some data from external devices. So sending data from microcontroller, it can be output data or input data. Output and input of data from a microcontroller to the external world is nothing but memory write and memory read operation. So whenever you go for read and write operation, you need you need two things. One, if you want to write, you need address where to write, and you need data what to write. Then reading means where from you, what is the address where from you are reading, and what you read, that is data. So you, here there are only two lines. One is, okay, I'll see you. uh, so speeds up to 3.4 megabits per second, multi-master, multi-slave. In case of SPI, single master and more than one slaves. But here, the beauty of the system is, or the most interesting fact is that this is a multi-master and multi-slave. Master means he controls, all others are slave. He is master. Okay, he can control or transfer data to other devices. And another device, any other in the loop, any other device can become master and all other will become slave. So I said two lines are SDA, serial data, and SCL. SCL stands for serial clock. SDA and serial clock. Now this is open collector. Here I want to say one thing. Open collector. Say, let's draw this line. Okay, let's draw a transistor. Okay, can you see it? See, open collector means within the chip output port. This is the output pin. This is output pin. Okay, this is output pin, and from where you have taken the connection. And normally this is open, so no resistance is connected in between with collector, because if you do not connect, if you do not uh, apply any voltage at the collector, the transistor will not be operative. The interesting fact of this open collector configuration is that, so this is open collector. Okay, uh, open collector, open collector. So advantage is it can be okay. Open collector. So this transistor is residing at the inside the chip, and here you are connecting the here in this port you are connecting output device. Okay, output device. So output so this the interesting fact why we go for this one is that any chip can be have can be it can be of there are two types of family. Sorry, it can be TTL type or CMOS. TTL, there is a definite supply voltage. For CMOS, there is definite supply voltage. But the beauty of this open collector is that it can drive any sort of any family of chip. It can drive TTL, it can drive CMOS, or a CMOS. It can drive any other device having any other voltage level. So how it is possible? When if you connect a resistance, and this is your VCC. This is supply voltage, can be anything. So thereby this is called pull up. This is open collector, and you are connecting a resistance. Thereby you can change the voltage level to drive the external device. Basically this is called wire and. Let's say if you connect multiple such devices here, you can connect multiple devices. Okay, so you have a line like this, you have a line like this, and you connect a resistance, and from here transistor are connected. Can you see my desktop? Or you can connect it here. So here also open collector circuits are there. So multiple devices can be connected here or here. So they might have different voltage. This VCC, let's say this is 12 volt. This can be 5 volt. Now, if you apply 0 volt here, 0 volt over here, they will be at, then transistor is cut off, they will be at high voltage. If any one of this transistor goes low, let's say if you apply here a 5 volt, then this transistor will be turned on. In that case, it will pull down the voltage of all in this line to 0 volt, because if this transistor is on, collector to emitter voltage will be almost 0. So it will pull down the voltage of all other devices. So this is the beauty of this circuit. Open collector, very simple interfacing between different voltage level. That's what I told you. And clock is not a traditional clock, normally high, kept high by the pull up, pulsed by master during data transmission. This is not a normal clock. Normal clock means it has got a repetitive time period, that is high, low. So it is repetitive in nature, but this clock is a special type of clock, normally kept high by the pull up resistor, pulsed by the master during data transmission. Whenever they are going to transfer the data, the clock, then they transmit clock, that is high, low, normal, square during data transmission, whether the master is transmitter or receiver. So this is going to happen. The clock is under the clock. Whenever data transfer is there, actual clock is transmitted. Otherwise, this clock signal will be high. Slave device can hold clock low if it needs more time. So suppose the slave is not ready to accept data, then it can hold the clock low. Okay. Master always initiate transaction, now operation. Most probably those who were working with microcontroller, they might be familiar with this chip at Mega 8. Is a very popular chip, one of the cheapest microcontroller, widely used. Master always initiate transaction, start condition, say serial data and SCL. So I told you it is high, but normally clock is high, low. Normally it is high. Then serial data, SDA. It will send address, the MSB of address and LSB of address. First it will send address. So it is address means it is sending some data. So that's why clock is regular. Then it will send a pulse, or it depends upon whether read or write, 1 and 0. Read means it will be 1. Then it will wait for acknowledgement. So address will be sent and read request will be sent from master to the slave. Slave in turn will send acknowledgement. Okay, I am ready. Then master will transmit data MSB and data LSB. After it completes its data transfer, again acknowledgement will come from the slave. This is how data transfer is done. Say this is the this is data byte and this is address plus read write. So start condition, address, data, acknowledgement, stop condition. Okay. So this acknowledgement is start condition and this acknowledgement is stop condition. Here this is acknowledgement data received, and whenever there is a transition, clock is high, and high to low transition means start, and again clock is high, and low to high transition indicates stop of sending a byte of data. Transmitter receiver differs from master and slave. Master initiates transaction, slave response. Transmitter sets data on SDA line receiver acknowledge. For a read operation, slave is transmitter. Who is reading? Data read. So it is this read and write. This operation is thought in terms of the master. Master is reading. So that means slave is transmitting data, and write, that means master is sending data to the receiver. So master is transmitter in write operation. Under read operation, slave is the transmitter. Master pulls SDA line low while SCL is high. That's what I have shown you in the beginning. Pulls low when SCL is high. Okay. Master pool SD high while SCL is high. Also used to abort transaction. So low to high means stop. This is to abort transmission. So now see here again address. Okay, data, then stop, and let's come here. This is master and slave. So the clock line, this port is also using open collector types, so that's why our resistance is connected and supply is connected through our resistance. Here also, that's why two resistances are there. These are required for open collector type port. So this is the master and slave. How fast can you run? The zeros and okay. In I2C transaction involves the following bits. Start. This is the format. Start. Then A0 to A6. A0 to A6 the 7 bits for address. So how many devices are there? 2 to the power 7 number of devices are there. Then read write bit, then acknowledgement received from the slave, then data. How many bits are there? D0 to D7 8 bits, then acknowledgement, then F. F means stop. Which of these actually carries useful data? So if a bus runs at 400 kilowatt, so this is an example. Let's see how it happens. So this is another view of the same thing. Start, slave address, read write, acknowledgement, data acknowledgement, then repeat start condition slave address. So this is the format of data transfer. A repeat start avoids release the bus and therefore prevents another master from taking over the bus. Here anyone can be master. So any slave can become a master. So that's why if you want to transmit continuously, you have to issue repeat start condition. Okay. This is what I've said. A is the acknowledgement. That means acknowledgement means a serial data. This will be low. A bar not acknowledged. SD is high. If it is low, that means it is acknowledged. If it is high, that means no acknowledgement. That means address is not received. S is the start condition, P is the stop condition, and C is hashed line are from master, and this is from data, master to slave, and from slave to master. these are the data formats. So already I have shown. Okay. Okay, types of I2C implementation. That is a byte-oriented interface. Data is handled one byte at a time. Processor interrupts a status byte when an event occurs. Bit-oriented interface. Processor is involved in every pass event when interface is not idle. Bit banked, implemented completely in software on two regular I/O pins of the microcontroller. So byte-oriented structure is very popular. So devices, what are the devices? So analog to digital converter, bus controller, bus repeater, real-time clock, deep switch, LCD, LED displays. So these devices can be used to connect with microcontroller through I2C bus. There are several others, erasable EEPROM, serial ROM, temperature voltage controller. So all these sort of device. There are some specific applications for certain types of I2C devices such as TV or radio tuners. But in most cases, general purpose I2C device can be used in many different applications. So the many different application means, so what I've shown in the last slide, there are various applications. Okay, writing, this is an example of start, then slave address 10101110. So 1, 2, 3, 4, 5, 6, 7. 7 is the then 0. And okay, slave address, then byte address, then say byte address. So it is addressing how many lines? 16 line address. So A0 to A7, A8 to A5. Slave address, this slave address, don't confuse with this address with this address. This slave address will identify a particular, and it will select a particular slave, and this address will send address in the memory inside the device, and this is the data to be written. So whenever 8 bit of data is transmitted, acknowledgement signal, no signal is received, and after acknowledgement, a high transition will indicate this stop condition. Okay. This is all about SPI bus. And if you have any other thing, okay, let's see. Not this one. So these are the another important facts. Complete I2C, that's read, write, acknowledgement. I have shown you data acknowledgement. This is the I2C transfer. Master writes to slave. Master writes to slave means this is start address, slave address, read, write, acknowledgement data. So this is 8-bit data, 16-bit data is written. And master writes to slave. So this is over. Master reads from slave. So master reads from the slave address, read, this will be read operation. In earlier case, it was write operation. So read means it is reading data. So receiving data means reading data. So data is transferred. Finally, it is a 10-bit and 10-bit addressing. There can be 1024 number of address, means types of device can be interfaced. Fast mode means 400 kilobits per second, and high speed means